So here's the second installment of the function gen project that I'm doing. I have built a bridge rectifier board. As you can see here, I've got the bridge rectifiers, two of them there and one down here, and I got the smoothing caps, and I got this PCB connectors to solder the wires into this and put heat shrink onto them. I didn't want to use normal connectors that you can just take off and put in, because after a while they get a bit dicky, so I'd rather just solder the whole thing into the PCB and get it over done with, because I'm not going to be moving around, changing things around after once I solder them around. So I just want them to be nice and solid. As you can see here, here's the back of it. As I said before, these capacitors are the type that they're the screw ones. So what you do, you just make a little track and you just screw it on and they get contact with the screw. Okay, so I got this section is for the plus 44, minus and plus and minus 20, plus and minus 5.2. So that's done. As you can see here, I'm gonna have standoff here so I can mount them like this into my enclosure. Okay, and here's the second bit. I've done the voltage regulator board. As you can see here, it's all done. So we got plus and minus. I used the LM317 and LM337 instead of using Xenodiode. As I said before, I was going to use Xenodiode, but I'll just use this. It's simpler, and what I'm going to do is I'm going to use a pass transistor to increase the current capabilities of the LM317 and LM337. So as you can see here, I've got a PNP and an NPN mounted on the heatsink. Then I've got a washer at the end. So because the body of these packages are the collector. So what you need to do, you need to use like a washer, so they don't short together basically. And what I've got here, I've got a screw, and I've got this, so I can tap down here to get the collector basically. As you can see here, these are the collector for this and that. So I got two here, I got another two there, and I've got one more here. But I think what I'm going to do is, instead of using this package, I'm going to use a different package for the plus 44, and I'm going to use the chassis of my of the enclosure that I have to use that to cool the transistor. The thing is, the plus 44 volt, my transformer is giving me 47 volts, so with a little bit of voltage drop, it's going to be 44 anyway, so it's not going to be much dissipation on the transistor. It doesn't have to drop that much voltage, so I can just use the chassis of the enclosure for a heatsink, because I don't have enough space at the back of the enclosure to put 3 heatsinks, so it'd be perfect just to put these two basically at the back of the enclosure to use the space to cool the transistors. Okay, now here's the voltage regulator board. As you can see here, I've already set it. Plus 5.2, minus 5.2, plus 20, minus 20. As you can see here on my voltmeter, it's 5.25. It's been set there. This is my dummy load. I'm just trying to test the regulation of the LM317. As you can see here, I'm pulling at the moment. Let's go to an amp. Okay, I'm pulling an amp at the moment, and we are at 5.13. The thing is, I haven't put the pass transistor on here yet. I haven't connected the pass transistor yet. I did test it before with the pass transistor, and I only get at 2.5 amp. I only get about 60 millivolt of voltage drop, which is perfectly fine. I'm not going to be pulling 2 amps anyway. So that is that. So this section is for the plus and minus 5.2, and this section is for plus and minus 20 volt. Okay, so if I just disconnect this, don't need that. We get the plus, we get the ground, and we get the minus. And if I get down here, you can see here, plus 20 volt, and then here minus 20 volt. So I use the blue LEDs for plus or minus 20, and the green LEDs for plus or minus, oh, there we go, plus or minus 5.2, and I have an orange LED here for plus 44 volts. So that's what I've done so far. The power supply bit is complete. I just need to put it into my enclosure. I'm going to show you the enclosure that I have. A couple of months ago I bought a device from eBay. It was, let me see what it was. I forgot what it was actually. Just put it here. There we are. I don't fit in the shot, all of it. We can all be seen. Yep, there we go. It's in the shot. I bought a filter. Basically, it was an electronic filter made by Stanford Research, and I completely forgot that I had this enclosure. But yeah, I found it today, and I think it's perfect for what I want to do with make my function generator, basically. Okay, now this is the amplifier bit. It's gonna go up here. You can see here. I've got these. That's gonna go all the way at the back, like so. One here and one there, basic. There's two of them. So I'm gonna go there. And I've got this. That's gonna go over here, like so. If I can put this on the shot. Down here. And what I need to do, I need to make a hole here. And I need to use this basically to connect into here. I can show in the, if you can see here, yep. These two go together like so. So then I can change the ranges like so. So I need to make a hole here into the enclosure and at the front, and put a knob to change the ranges of the filter. Okay, this is the original, I think, for the function generator, which I bought on eBay. So I got all the knobs as well with it. So that's gonna go at the front. If I can just take this here and get there we go, into the shot. I've got this, so I can change the frequency here at the front. So I'm gonna need another knob for this, for the front, to put a hole here, and then I'm gonna make a couple of holes here for the, obviously, the output of the function gen. So this is what's gonna look like. I already mounted the transformer here. I've connected the wire for it, for the on and off switch. Again here, that's the on and off switch there. This is gonna be mounted here with the standoffs, like so. And then the rest of the stuff, I might just mount them on the corner here, and this probably just leave it somewhere here. As I said, I'm gonna use, I think I'm gonna use this side of the chassis for the transistor that I'm going to use for the plus 44 volt. And what I'm going to use is, if I can get it, yeah, I'm going to use this package, this transistor, and just basic get a little washer. So because this tab is the collector, so I'm going to put a washer there so it doesn't short to the body. And I'm just going to mount it there. So that's what I've done so far. I'm nearly getting there. And then what I'm going to do is I need these connectors to connect the relevant blocks together. I'm not 100% sure if I'm going to use a attenuator in this. I might just make it the way it is and just use a different box or different thing to get the attenuator coming out of the device, or I can just mount the attenuator here. I have enough space for the attenuator anyway, so I might mount it here and just use switches at the front to switch through the attenuation of the signal. So that's what I've done so far. The next thing to do is just connect this to the front. Connect this to the front over here. Connect the power. Put power through the relevant blocks. Test all the blocks to make sure everything is working. Check the regulation and the power, and see if there is any ripples or any problem with the power, any voltage drop or anything like that. That's what I gotta do. So I might connect each block on its own first, make sure that everything is alright, then connect everything together at the end, because I think they all three of them do share the minus 5.2. So I need to make sure that the 5.2 doesn't get basically pulled down too much. And that's it. That's what I've done so far. So until next video, then I'm going to connect the relevant blocks. Goodbye. So I'll just do another shot. And that's the front of the enclosure. And that is the inside. That's the IC power, where the power is coming. Got the transformer. It's got the switch. The front here. Smoothing caps. Gonna be connected there. The amplifier, the oscillator, and the divider, and oh, I forgot what it was. It was divider and the filter, sorry. And we've got the voltage regulator board down here.